Hello everyone. I'm reporting to you live and in stereo from my home because it is lockdown and it is currently November, hence the moustache, so please excuse that. Uh, my name is Sachin Nanavati and I am a current fifth year medical student at the University of Liverpool and a postgraduate sports scientist at the University of Leeds where I conducted this research. And can I just say, as a 23-year-old, I am so humbled to be able to present to you all at this conference, and it is in an area of research that I am so fascinated in, and I can't wait to share this with you. So we conducted a review, myself and my colleague, Professor Stuart Eddington, a systematic review of the angiogenesis in response to muscle contraction in endurance versus resistance training. The gap in the research. So why did we do this research? So first of all, let me tell you what angiogenesis is defined as, and it's defined as the growth of blood vessels from the existing vasculature. And it is currently a well-documented finding that chronic exercise is a stimulus for angiogenesis. And what I mean by that is, if I asked one of you now to run for the bus in the morning tomorrow, you wouldn't notice much difference. But if after 6 weeks I asked you to keep doing that every single day and running for that bus, and we were to take a muscle biopsy of your leg muscles, we would see that there has been an extension of the vasculature within the muscle. And that is a finding that's been well documented over the last 40 years. But what remains to be seen is how different types of exercise regimens affect this. So what I looked at is specifically endurance versus resistance exercise regimens, and to see how, if any, effect is produced and which type of exercise produce a greater response. And this review stratified a comprehensive selection of studies to determine the extent of the angiogenic response in a variety of different exercises. So the methodology, how did we go about doing this? So as you can imagine, I had to find all the relevant material that there was on this area of research. And after a search term was generated, I used a search term within PubMed and other databases to find 2001 papers. I then narrowed these papers down using my inclusion and exclusion criteria, and managed to use 19 studies, which were then used for meta-analysis. The inclusion criteria were as follows: a full-length article in an English peer-reviewed journal. It had to contain an exercise regimen where muscle biopsies were taken both pre and post-intervention, so I could monitor the change. Studies that indicated the measurements of capillary density, capillary to fibre ratio, and fibre area. Don't worry, I will explain what these are on the next slide. And had documented the muscle sample preparation method. The reason for this is different muscle sample preparation methods would produce slightly different results, so I needed to make this the same so I could standardize this. And finally, muscle biopsies extracted from the same muscle, i.e. we used a vastus lateralis located in the quadriceps of your leg to allow for valid comparison of the changes in the capillary network. And exclusion criteria were cardiac and smooth muscle studies. We weren't looking at this, we were only looking at skeletal muscle. And any mention to pathological angiogenesis without relevance to exercise-induced angiogenesis. And finally, animal studies. We weren't interested in animal studies, we were only looking at this response that was generated in humans. And as I said, finally, this data was gathered and a meta-analysis was undertaken to look at the patterns within different study groups. In terms of the outcome variables used, we use capillary density, which is defined as the number of capillaries per millimeter squared in a cross-section of skeletal muscle. And we also use capillary to fibre ratio, which is defined as the total number of capillaries within a muscle section divided by the total number of fibres within a muscle section. Now, these two outcome variables are the measure of capillarization, and these are the most important for determining whether a pro-angiogenic effect has occurred. More specifically, capillary density implies the relative exchange surface area within the muscle, and capillary to fibre ratio is a numerical ratio indicating whether angiogenesis or capillary rarefaction, i.e. the opposite of angiogenesis, has occurred. And finally, we looked at fibre area, which is defined as the cross-sectional area of muscle fibre within a section of tissue. And we needed to look at this in conjunction with capillary density because an increase in muscle fibre area can overshadow the capillary density. So it could also look like that a reduced capillary density has occurred when this isn't the case. It would only be due to an increased fibre area, as I will explain later. So the results, what did we find? Just to start off first, if you look at the forest plot on the right, we used SMD, which stands for Standardized Mean Difference. What is that? What that is a summary statistic used in meta-analyses and is used when the studies measure the same thing but using different methods. The standardized mean difference expresses the size of the intervention effects in each study relative to the variability observed in each study. And as you can see here by this white diamond over here, it is in between 0 and 1, as in relative to this x equals 0 line, which means that a moderate increase has occurred overall. Also, if you divide it into the subgroup analyses of resistance and mixed regimens, we group them together because they both had elements of resistance exercise within them. And endurance regimens, you can see that endurance had a more profound increase in capillary density than resistance and mixed regimens, and which is basically outlined here. Out of 17 total endurance training study groups, results showed only 1 would decrease CD, 7 with no significant change, but 9 had an increased CD. And out of 9 resistance training groups, 0 had a decreased CD and 7 with no significant change, but only 2 had an increased CD. And 52.9% of the studies for endurance training showed an increase in CD compared to only 22.2% in resistance training groups. The capillary to fibre ratio, again looking at the forest plot first, there was an even greater response overall. So we could say a moderate increase has occurred here. And again, as you can see, there is a slight discrepancy between endurance and mixed and resistance as categorized by the 2 subgroups, but you can see that there is a slightly greater increase in capillary to fibre ratio in endurance regimens. And when we did a further subgroup analysis and we split resistance into resistance and mixed and endurance regimens producing 3 categories, we could note that there was a greater gap between resistance, SMD, and mixed regimens and endurance. So resistance would be at the bottom, and then mixed, and then endurance, indicating that the more endurance related activity there is, the greater the angiogenic response. Out of 33 study groups, 22 results showed a significant increase in capillary to fibre ratio. No studies exhibited a decrease in capillary to fibre ratio in this case. Results of this review had generally, but not exclusively, indicated that the higher the target of VO2 max, the larger the increase in capillary to fibre ratio. What do I mean by VO2 max? Well, VO2 max is the maximum of or optimum rate at which the heart, lungs, and muscles can effectively use oxygen during exercise, and it's used as a way of measuring an individual's aerobic capacity. Unaffected capillary density or capillary to fibre ratio in endurance training studies were noted in only a minority of cases. And finally, for fibre area, we noted that there was an increase fibre area more strongly associated with resistance and mixed regimens. As you would expect, resistance exercise, i.e. bodybuilding, weightlifting, is associated with muscle hypertrophy to a greater extent than endurance regimens. So this is why this was expected. There was no significant difference between type 1 and type 2 fibres in terms of their hypertrophy. And when we did a further subgroup analysis, I removed the mixed regimens again and separated them into 3 separate categories. The overall SMD for resistance groups for fibre area markedly rose from 0.41 to 0.52, which means that it is the resistance regimens that are more responsible for this rise rather than the mixed regimens. So then, our discussion. What did we find out? Well, there is a larger pro-angiogenic response in endurance training regimens. Now, this was the main finding of the systematic review. And we believe this to be because there is a greater strain on the central and peripheral cardiovascular system in endurance training regimens when you compare them with resistance training regimens. We also believe that endurance training regimens induce greater shear stress on the capillary bed within the capillary wall, and this is likely to induce pro-angiogenic factors such as VEGF to stimulate the pro-angiogenic cascade. In terms of age, there was a general tendency for CD to increase in long-term exercise for some regimens, but there was an apparent rarefaction that we found in the minority of cases. And we looked into this further, and we noted that these study groups in the majority tended to have an older cohort, i.e. Patients above the age of 60. And we've noted that upon further research that older cohorts are more likely to experience rarefaction, and when you combine this with the pro-angiogenic response in the exercise, it would just dampen the response, leading to no significant change. The length of the regimen, longer exercise regimens tended to have a greater angiogenic response. Now, although there isn't an exact timeline of when angiogenesis can occur, as in what is the lower bound, we noted that in Hirschley et al. Of 1995, there was a relay race that occurred over 30 days, every single day, and from Paris to Dakar, and there was no pro-angiogenic response exhibited. And we found that in the majority of our studies, the pro-angiogenic response was noted within the 6 to 8 week mark, with 6 weeks being a cutoff point of the lower bounds of when pro-angiogenic responses are likely to occur, which is something that has not been well documented prior to this study. The frequency of the regimen. Now, 10 out of 14 regimens were 8 weeks in duration and operated between 3 to 5 times a week. And we noted that these all had a pro-angiogenic response. A study by Bell et al. In 2000 showed that no increase in capillary to fibre ratio had occurred, yet it was operating at 90% VO2 max for 30 to 42 minutes at a time. We concluded that because it was only operating twice a week, that this was insufficient for a pro-angiogenic response to occur. Higher intensities of VO2 max generally resulted in more pronounced capillarization response. Now, pre-review hypotheses based on the pioneering research by Anderson and Henriksen in 1977 and Dennis et al. And Inger of 1977 had predicted that intensities of 45% of VO2 max would be insufficient to induce a pro-angiogenic response. From this study, we concluded that studies operating within 50 to 65% of VO2 max exhibited a moderate increase in angiogenesis, and those operating at 75 to 90% had an even greater pro-angiogenic response. It is unclear that what the upper bound of this could be, as it is believed that prior to this study that above 90% could be detrimental to the pro-angiogenic response. But from this review, we generally found that the higher the VO2 max, the greater the angiogenic response was. We noted unaffected capillarization in a minority of endurance training regimens. And we believe this to be because some of these studies, when looked at more closely, had patients who had long-term chronic illnesses such as COPD, and long-term chronic illnesses are associated with pathological rarefaction. So although there was an increase that was likely to have occurred during the exercise regimen, the simultaneous effects of the rarefaction caused by the COPD and other chronic illnesses has caused a dampened response, leading to no significant change. And this was noted in a minority of other studies that we had taken on board, and this was noted in cardiorespiratory illnesses. Finally, we noted an increased muscle fibre area in resistance training regimens, but an apparent decrease in capillary density for a minority of studies. So in summary, our main findings were that a greater overall increase in capillarization was associated with endurance when compared to resistant and mixed exercise regimens. Higher intensities of VO2 max generally resulted in a more pronounced capillarization response. Cycle ergometer training at moderate to high VO2 max was a consistently useful method of endurance exercise to achieve a pro-angiogenic response. And finally, angiogenesis is in response to muscle contraction is dependent on numerous factors, including the length of the exercise regimen, the frequency at which it operates, the age of the participant, and the general health status of the participants. And as you can see on here on the right, finally, is the poster that myself and my colleague drew up, which summarises everything that I've just talked about in this presentation. These are the references. And thank you very much for listening to my presentation. If you have any further questions or would like access to our paper, please email me on sachin.nanavati@hotmail.co.uk or ask me directly during the conference. Thank you very much.